seen my father speak before?
Yay.
How many of you completely understood everything?
Very
You
good.
guys have all probably got the Artemis right, and maybe me, but this, because there's so much of it, and it's a comprehensive architecture that takes you from the Earth to Mars forever, and it's all there. These guys have done a great job in a very short period of time of tying the pieces together and explaining some really difficult concepts. So we're going to run the video. It's going to go for about 10 minutes, and then we'll come out here, do questions and answers. I've never done anything like this before with my dad, so this is going to be fun, interesting, and we'll have a good time with it. Okay?
All right.
So with this mission, our primary goal is to establish permanent bases on Mars, but on the way we can use the Moon and Phobos as stepping stones. We're going to be starting off with some international moon bases, and then from there we can move to putting a smaller base on Phobos, operating robotically some cranes and rovers on the surface, and then actually once we get to about 2040, fully establishing and manning a base on Mars. The moon bases are intended to test all the technologies that we need for the later missions that we're going to do. At the same time, we're also doing some testing on the Earth and Hawaii and other places to make sure that all the modules are ready for the Martian surface and in space.
We'll have 3 bases at the moon, one at the far side, one to the near side, and the most interesting of them all, look at the South Pole at Shackleton Crater.
Each lunar base will be composed of 3 second-generation exploration modules.
It is at Shackleton Crater where we will produce rocket fuel from the water extracted from the icy regolith from the moon. We want to produce rocket fuel from the moon because bringing all the rocket fuel to go to Mars from Earth is extremely expensive due to our Earth's high gravity and atmosphere.
The Cycler is a manned spacecraft designed for delivering astronauts to Mars and Phobos safely and efficiently. Analogous to a shuttle bus on Earth, it will be orbiting the Sun and meeting Earth and Mars at regular intervals throughout the mission.
The Cycler vehicle will orbit in an S1L1 trajectory. This trajectory allows for a large vehicle to remain in orbit and for smaller taxi-like vehicles, known as the human landers, to bring humans to and from the Cycler. The S1L1 trajectory is a heliocentric orbit that uses gravity assists at both Earth and Mars to minimize the number of propulsive maneuvers necessary. This solution allows for a larger living space for the humans on their journey from Earth to Mars. Because the orbit opportunity exists each synodic period, but this is a 2 synodic period cycler, we will use 2 cycler vehicles to maximize the number of trips from Earth to Mars. An important consideration for long-duration, low-gravity human spaceflight is the time of flight for the crew. The S1L1 has a time of flight from Earth to Mars of only 138 to 183 days. This short duration allows for the crew's mental and physical health to be maintained. Cycler vehicles will also serve as communications satellites. Once both cycler vehicles are in orbit, we will be able to maintain continuous coverage, even when Earth and Mars are in solar conjunction.
To begin, a boost vehicle will be launched to low Earth orbit. After this, 3 human landers will be launched and docked separately with a boost vehicle. Then, this 4-vehicle assembly will be boosted out of Earth's orbit to meet with a Cycler using a hyperbolic rendezvous.
To get the crew from low Earth orbit to the Cycler, we will need to perform a hyperbolic rendezvous. This is dangerous. If anything goes wrong, we could lose the crew. Because the